really official now. Okay, I'm going to go ahead and get started. Is this too loud? Okay, my name is Stacy Main. I did my research here at LECOM with Dr. Kaleza. Okay, to get started, ASD is a disability associated with neurodevelopmental defects. It manifests in neuronal dysfunction, which results in communication, social, and behavioral challenges. The CDC estimates that one in every 68 children have been diagnosed with ASD. And it's 5 times more common in boys than it is in girls. So valproic acid is used clinically to treat epilepsy, mood disorders, and in the prevention of migraines. However, it has been known to cause cognitive and behavioral teratogenic effects that are related to ASD. Okay, so what we're focusing on here is the cerebellum and how everything is affecting that organ. So most of you know that the cerebellum is involved with motor function, but it also plays a role in fine-tuning motion and higher order functioning such as language. So within the cerebellum, you have Purkinje cells. And the importance of Purkinje cells is that they release GABA, which is an inhibitory neurotransmitter. And what this does is it helps to regulate jerky motions. And what you'll see characteristically in some people with ASD is that they often have these really jerky motions. So that's where you would see some of the dysfunction. And I don't know if you can see it really well, probably better on the TV, but here this is a parasagittal section of the cerebellum, and just getting closer in magnification. So you can really see how branched and extensive the dendrites are. So within the Purkinje cells, you have something called calbindin. Calbindin is a calcium-binding molecule, and its importance is that it modulates the release of these synaptic vesicles within the Purkinje cells. And so this is another critical player in controlling the precision of fine motor coordination. Okay, so our hypothesis is that a double dose of VPA given to these pregnant rats will impact the morphology and function of the pups. So this is a timeline of our research. E0 denotes embryonic day 0, and P is postnatal. So on E7 through E12, we gave the pregnant rat a peanut butter meal, and this was just to disguise the VPA. So in our testing group, they were given VPA on embryonic day 10 and 12. The rats gave birth at P0, and then they were weaned at the traditional weaning stage of P21. On P21 through P26, I handled each rat for about 5 to 10 minutes each. That was just to familiarize themselves with me. So when they further did the behavioral testing, they weren't like, stranger danger, let's focus on what we're doing. So then on P27 through P30 is when we went ahead and did the behavioral testing, and we did morphology testing as well. Okay, so this is just a summary of my aims. I'm just going to go ahead and get started into aim 1. So for our first aim, we analyzed the size of the Purkinje cell somata, which is their the cell body, and we compared that between VPA and control rats. So how did we do this? So we had our cohort of rats. We anesthetized them, and then we transfused them pericardally with normal saline. That was followed by 4% paraformaldehyde, which is just simply a fixative solution. The cerebellums were excised and put into a chiroprotective solution. That was because later we sliced them with a sliding microtome with a freezing stage. Those sections were then mounted on a microscope slide and stained with Gemsa. Gemsa staining is nonspecific, so I'm able to view the entire cerebellum, all the lobes and the cells. Then I traced each cell at the distal end of each lobe, which I'll show you here. This is the parasagittal section. I went ahead and labeled all of the different lobules. There are 10 in total. So I traced the most distal end of each lobule, and then I compared those sizes between VPA and control. And this is what we found, that in every single lobule globally, there was a significant decrease in this cell size in VPA rats compared to control rats. Okay, and I just put the slide here so you can get a more close-up version of what this looked like. So on figure A, this is a normal, healthy cerebellar lobe. And as you can see, the Purkinje cells line up very nicely along the granule layer. They're circular, they're in line. This is what it should look like. In figure B, this is a rat that's been exposed to VPA. And what you can see is, maybe you can see, is that the cells are very staggered. They're not circular in shape. They're very abnormal. So this just gives you an idea of how dramatic these effects were just physically. So moving on into the second aim, what we looked at is we compared the proportion of calbindin positive Purkinje cells to the negative in control in VPA. So I'm not going to read all that. It's kind of redundant. We used the same steps we did for GEMSA, except instead of GEMSA staining, we incubated the sections in a primary antibody that was specific for calbindin. Secondly, we put those sections into a secondary antibody, which was tagged with a fluorophore. And that's important so we can view these sections under a fluorescent microscope. So this is what the sections would look like, or what they do look like. In figure A is control, and figure B is the VPA cerebellum. And what you can see is that outlining in the granule layer of the control are these yellow cells. This indicates positive for calbindin. And what you see in the VPA is that there are a lot of red cells, and that indicates a negative for calbindin. We can see the red and we can see a negative because we've used a stain called Nissl. And Nissl, like GEMSA, is nonspecific, so it stains everything. This is how we know that there are actually cells there, and we can count a negative cell, so it's a control. Okay, and this is what we saw doing this experiment, was that, again, globally, across all cerebellar lobules, there was a significant decrease in the percent of calbindin positive Purkinje cells in the VPA rats compared to the control. Okay, I put this video, I don't think you can see it, but you can see on the TV. What this actually is, it's not a video at all. It's a lot of images that I've stacked together. So when I cut the cerebellum into sections, I'm cutting it at 40 microns, and I can't express to you how thin that is. It's like a wet tissue. But using a confocal microscope, which we used at Penn State Barron, we're able to view a section at like half a micron thick. So it's so thin. So then I took these sections, I squeezed them together, spat it out, make a video. So what you're actually looking at is you're looking in like a Z orientation into an axis. You're looking through the lobule and seeing more of a 3D structure of these dendrites. With this information, we were able to reconstruct a dendrite. And that's what you see in this shoal analysis, where it looks like a target. So what we were able to gather with this information is we can now look at how extensive the branching is, how far this branching extends out. So in the VPA-exposed rats, what we saw in figure C is there is a decrease in the number of crossings. That is just counting up in shoal analysis. You count the crossings. However, both of these cerebellums had the same molecular layer. And what that means is they both had the same amount of room to grow. So there wasn't that, it was just smaller, so the cells couldn't extend. They both had the same opportunity to grow, but they didn't. So in figure E, what I'm showing is that there was a significant decrease in the diameter of the primary dendrite. And what the primary dendrite is just this very first branching root of the Purkinje cell. And that's important because if that breaks, well, you lose communication. So this is just a visual of what a typical control and VPA cerebellum with dendrites look like. This was another observation that we noticed exclusively in VPA-exposed rats were Purkinje cells that were ectopic. We never once saw this in a control rat, and that was just something interesting I wanted to show you. Okay, so for our third and final aim, we examined the effects of VPA on motor coordination and balance. So these are the 4 behavioral tests that we did. I'll go into each one. All right, starting with the writing reflex, this was conducted on P27. And what we do here, this is Dr. K in the video, is that you hold the rat down on its back, and then you release the rat, and then you time how long it takes for the rat to flip over onto all 4 paws. Because they are so fast, whether they're exposed to VPA or not, we recorded them on a GoPro, and then I digitally reduced the speed using iMovie. So with that, we were able to get an accurate reading of how long this reflex actually took. So having said that, what we saw is that in the VPA-exposed rats, there was a significant amount of time, an increase compared to the control that it took for them to flip over. Okay, so our next one, we did a footprint analysis. So we painted their little rat feet, which is harder than you would think. And so we painted their feet, and we let them walk down a paper runway. And then we we measured their forestride, hind stride, and gait. So what we saw is that in both the fore and hind stride, there was a significant reduction in the length that the VPA rats took compared to the control. However, there was not a significant difference in their gait. If I can hypothesize as to why that may be, well, rats have 4 legs, so balancing action is probably a little bit better. However, there have been many studies that are correlating those with ASD with ataxia. So it is something that we see in humans, but it's kind of hard to compare the two when you have 2 legs versus 4. Okay, so the next thing we did was we used a rotor rod. And on P30, we assessed their coordination using a constant speed rotor rod at 16 RPMs, and then an accelerated, which started at 3.5 and adjusted to 35 RPMs. That sounds really fast, but it's not. It's really slow, and the rats were incredibly bored, and so were we. But what we saw is that there was not any sort of significant difference between the VPA and the control rats. And this was actually an anticipated result because what we're looking at is how ASD is affecting fine motor coordination, very unexpected things that you would need for balance and coordination. The rotor rod was very monotonous. They have a pretty wide platform to walk on, so this is expected. So to better isolate fine motor coordination, we did testing using static beams or wooden dowels. So what we did is we used 2 different diameters, one of 25 and one of 12 millimeters. This was conducted on P29. We let the rats traverse the beam, and then we timed how long this took. We also looked for footfalls, which just means how many times their hind legs slipped from the beam. So what we saw with that is in the 25 millimeter dowel, there was a significant increase in the time it took for the rats exposed to VPA to traverse the beam. We also noticed a significant increase in footfalls and in fails. A fail is simply when the rat falls or takes over the amount of allotted time max, which was 40 seconds. We also saw the same exact results in the 12, which you would expect. It's just a little bit harder, so the results are more prominent, but the VPA rats did significantly worse than the control rats in all of these tests. Okay, so in conclusion, what we saw with the VPA exposure was that the Purkinje cell stomata had a significantly smaller cell body. So this indicates that the VPA is impacting neuronal growth and development of these Purkinje cells. The ectopic cells that I showed you a little bit earlier, this indicates that there is some sort of interruption in cell migration. Also, we saw a significant decrease in the Cal-bindin positive Purkinje cells. So with these disturbances in neuronal growth, morphology, and the decrease of Cal-bindin positive Purkinje cells, it is directly correlated to what we saw in the motor movements, that we saw poor coordination in the VPA rats. So the combined results of these behavioral tests reveal how structure determines function, or more specifically, how these cerebellar impairments can result in functional abnormalities. So that's all. Any questions? No.